the question states that you own a goalparser and that can be, or that can interpret a string command. And the string command consists of an alphabet G, left and right parentheses, then AL in left and right parentheses also in some order. And so we are to return the goalparser interpretation of the command. And so taking this input command here, it goes from here to here. So basically, there's a mapping. G maps to G, left and right parentheses map to O. Then AL in left and right parentheses maps to AL. And the final concatenated result is goal. And so that's what we want to tackle in this problem. And I think it's straightforward. So let's head over to the implementation. All right. So um, with this goalparser interpretation, I believe straightforward. So, but two ideas come in mind. So, idea one and idea two. All right. So, with the first idea, I mean, it's simple. We just replace G with G. Okay, G is the same G. So, replace left and right parentheses with O and replace AL in the parentheses with AL. All right. So, I think that is straightforward enough. So, you're just going to replace each of the pattern and then return the answer. All right. And so I think that's straightforward. But with the second approach, um I believe we can only go with this, but it's fine. With the second implementation, we would iterate through each character by character, and then once we see a pattern, we make an interpretation. So we go through character by character. So G left parenthesis, open, that's right parenthesis and stuff, and we just do our mapping. So the idea here is iterate through character by character. Then do we see the pattern? And so once we see the pattern, we just make the interpretation. All right. And so um, I believe in both cases, the time complexity is going to be um, big of n over here. I think same for this idea. All right. The reason being that for the second idea, we look at each character once. All right. So we iterate character by character. But when we are using the replace it internally scans the string. All right. So that's why in both cases it's big O in. But what do I mean by make the interpretation? Right. So let's take this idea here. All right. So G maps to G. All right. So when we look through character by character, we just comparing the string G, which is of length 1, and this particular string, which is of length 2, and this particular string, which is of length 4, right? And so these ones will end up being the step sizes. All right, so the step size is actually going to be variable because in case we see the string which match this kind of pattern, we are going to make an interpretation as an O, right? In that case, we are going to actually step two or step twice. The same for this. And the thing is, once we do this, and I don't think we have to even compare the G because once you see a G, it's still a G. All right. And so let's start with let's start implementing the idea too. Let's see how it is. So we will start with the Java. So I'll just copy all this to C++. So I'll just copy Java. Okay. All right. So we are supposed to return a string. All right. So this is the idea. We follow through the idea. So I iterate through character by character. Once you see a pattern, you make the interpretation and keeping in mind our step sizes. Okay. So We are going to use string results. Okay, so we can go ahead and use a string, but um, we will end up so there's a general rule in, let me go here. There's a general rule that we have to take notice of. All right. When we use a string, strings are immutable. All right. And so once we use a string and we use something like, let's say if I say string A is equal to um A, and I do something like A plus, let's say another string B here. Now, A plus B, what Java keeps allocating, if this ends up in a loop, Java keeps allocating new memory and then copy the old and the new over and over. All right. And so if I do A plus B, since it's immutable, we can't even change. It's not stored in A new memory is being allocated, and I have to you store the results. Even if it is like that, it creates a new memory. The new memory is stored in A. So strings are immutable. And so we have to take note of that. We also have the string builder, and with string builder, it's mutable and faster. And the string buffer, with the string buffer here, um, if you want something which is thread safe, but okay, but it's slower in some situations. All right, it's a slower. All right. So the recommended one I think is a string builder. So let me change this. Let me use a string builder. All right. So string builder, my result is equal to a new string builder. All right. And what we do is that we iterate through character by character. And this, since our step size here is going to be variable, um, I can use a for loop with two conditions, or I can just use a while loop. So let's say if I'm using a for loop, I can just say for and I is equal to 0, then I is less than the command dot length. All right, so I'll not put there a third condition because if I end up doing I++, I'll be iterating through everything, which is what we want, but our step size is variable, it's not fixed. So let me take this then from there. All right, so once we iterate through, do we see a pattern? So which pattern are we looking for? So if the um, command dot char at this particular I, so if we have a string, let's use this as an example. All right, so if the char at I, so I will end up being here, is G, then what do we do? If the command dot char at that particular I, when it's equal to a G, then we make the interpretation, or interpretation is just adding it to the result. So results dot append, we append the G, and we do an I is equal to I plus 1. That's our step size. For the second case, if when the command starts with an open and close parenthesis, so when the command dot starts with, and so we can look at the start with. The start with takes a particular string, and we can put in the offset here because our step size is variable. All right. So the result dot append and O. All right. We can just even append. No, yeah, that's fine. Okay. So our step size over here for O is 2. So I plus equal to 2. Then our third condition or our third pattern, I'll see if the command starts with, oh, Sublime. Okay, so if it starts with AL offsets at that particular I, then our results dot append AL, I plus equal to 4, because that is our step size. Our step size here is 4. Okay, so all said and done, we just return the results. But this is a string builder, so our return type is a string, so we just return result to string until we test it. Right. So this is our test. So let's test it. Okay, so command dot starts with has an issue. Starts with. All right, so starts with, starts with. All right. Plus path. All right, so our test one was successful. So we go ahead and copy all this here, and we submit. Okay, and so we see 105 out of 105. This case passed here. Okay, so that is straightforward, and we can look at the second idea here, with the idea two over here. Oh, that's the idea two. So the idea one over here, where we replace each of the pattern. All right, so let's make this. Let's copy all this. Okay, we already have that, so we can just clear this. All right, so when we look at the replace, so I can see replace Java. So when we look at the string method, I can just search for replace, and with the replace, um, I can use a char sequence, and that's my target, and I can do a replacement. All right, or we will replace first, but we are not interested in this. We're interested in the replace. All right, so returns a string resulting from replacing all occurrences of old char. So you can, if you have a char, if you have a character sequence. So that's what we do here. We can just return the command, the replace. What are we replacing? We are replacing this. Since G maps to G, what we need is this particular string here. So we are replacing every occurrence of this with O. Then after that, we will replace every occurrence of AL, open and close parentheses, with the string AL. All right, and that should also work. So when I run my test, all right, it should pass. All right, so one successful test. We can copy that and also go back to our interpret. Okay, all right, that's fine. And we can just submit the code as well. And you see it's also passed, right? So 105 out of 105 test cases passed. All right. So that is it for Java. And we can do the same thing for Python. So I can switch this and submit the same solution for Python 3. So I'll copy this, come here, take off the self. And so I'm using the replace, I can just return the same thing, return the command dot replace. I think it's the same command that we had in Java. think it's the same thing here, so I just I just copy. I think they have the same, so please just follow Python syntax. Okay. And I can just test my good. So I have that command replace. So I'm interpreting. So this is the name of my function. Oh, okay. It's in there. So test main.py and it runs. So you can submit the same solution here for Python 3. That was okay. But how did it? Okay. And so submit. All right. So 105 out of 105, this case passed. And when you're supposed to, if we were following the same approach with Python, with with the second idea, where we actually threw character by character, we can do that. And so, just as we did for the Java, we had a string builder, if you remember. So we have to find a way of building our string in Python. And so in Python also, when we use the plus, all right, when we use the plus also, we create a new string in memory every time. All right. So when we see, let's see, a plus b, all right. So it's the same thing, the immutability of string in um strings are immutable in, in Python as well. All right. So when we don't have a string builder in Python, so our results here is going to be a list. All right. We start indexing at 0. And so you see, while the I is less than the length of the command. Wow. Wow. Okay. Wow. Okay. So if the command at index I is equal to a G, then what we do is that we do a result dot append. We append a G there. And the same thing, I think I'm writing Java. So the same thing, our step size increments to 1. All right. So I leave the command at I to I plus 2, all right, is equal to open and close parentheses. Then we append an O in there, all right. And the last condition, if the command at I to I plus 4, all right, if we see something of the string AL here, you're going to append AL. And with this our step size, we forgot to increase our step size. I plus equal to 2 and I plus equal to 4. All right. So so it's appending to the result. So we just convert into a string, because our return type is a string. So we just return, we use our join, the results. All right. So let's test our program again. Um, all right, so it's run. So I can just go and copy all that and move here and just indent this and submit the solution. Okay, and also end up passing. So 105 out of 105 test cases passed. All right. So I think that's the end of this particular problem. See you guys in the next one.